All right, today we're going to talk about visualization of statistics concepts. And the main thing that students struggle with when they say, that, oh, I'm bad at math or I'm bad at statistics, is that they're really confused by the huge number of vocabulary words. There's like all these new words. There's like new words for everything in statistics. And then they're also confused by these abstract concepts. These concepts are difficult to understand. And they may have had a class perhaps in the past about math or about statistics where somebody just kind of went through those vocabulary words or those concepts really quickly and in a very abstract way. And honestly, it's just really difficult to understand. So what we're going to do here is we're going to make it super, super simple. And this is really statistics for people who, previously thought they were bad in math. And by the time we're done, because we're going to use something very concrete, something you've held in your hands in the past, like a potato, you're going to not have any trouble understanding any of these concepts. They're going to be very, very simple to you, and we're going to take it nice and slow, and the vocabulary words are not going to be confusing because we're going to put it all into everyday language so you understand what we're talking about. Okay? You'll recall that we bought a bag of potatoes, and Professor Richardson used the widest point as the length of the potato, and she used the narrowest point as the width of the potato. And then she recorded those values on each potato using blue painter's tape. So later on, we'll talk about this sample of 24 potatoes. Because after all, we knew that we couldn't measure every potato in the world. So we just took a convenience sample. And what that means is it was just convenient or easy for us to go to the supermarket and buy a bag of potatoes. So people who are performing statistics projects or statistics research, they often ask themselves, is this a really good representative sample that I'm using? So questions like, are we really randomly selecting potatoes? Or did they end up in the same bag at the supermarket because of their length? If they were chosen by the people who bagged the potatoes by length, then I'm not really getting a good representation of, how long a potato is. Another thing that statisticians or people doing statistics research ask themselves is, was there other bias in selecting the data? Was I biased when I selected the data? So for example, all of these potatoes, because they're in a bag, they're coming from the same farm. But is that potato farm really a good representative of all the potato farms in the world? Maybe they're using different farming techniques that are going to yield different results. And other questions we ask about statistics is the sample going to yield reliable data? So is that something, when I come to conclusions or Professor Richardson comes to conclusions, is it going to be something that another researcher can recreate and come up with the similar results? How reliable is it by using just one bag of potatoes here? And then finally, we ask ourselves, is the sample valid? Is this a valid way of testing our hypothesis? So you remember our hypothesis was that as potatoes get longer, they also get wider. So maybe it turns out that we purchased a bag of extra wide potatoes. So maybe our research is therefore not valid because it's not really a good representation of how potatoes are normally. So we're going to leave all of those questions for later on for when you do your research report. But for now, let's just visually examine the data that we collected. So in this photo, what we've done is we've lined up all of those potatoes that came in the bag, and there's 24 of them. We lined them up from this sample set. We lined them up in length order. So notice how the potato with the smallest length is on the left, and the potato with the longest length is on the right. And all the potatoes are sorted in length order from left to right. So most people doing statistics organize their data in that way. The smallest number is on the left, and the larger numbers go on the right. So one important thing to notice is that the ordering of the potatoes has absolutely nothing to do with the width. We did not even look at the width when we went ahead and put the potatoes in order. So we could have done that if we wanted to, but there's no guarantee that they would have showed up in the same order. So for now, we're only considering the length of the potatoes. So here you see a close-up of that same sorted row of potatoes. There are those 24 potatoes in our sample. And in statistics, we frequently examine just a single measurement, in this case the length of the potato, all by itself. We call this univariate analysis. So univariate is a fancy word for one measurement. Uni means one, like a unicycle has only one wheel. And variate means that we're going to look at how those measurements vary, or how much the potatoes are different from one another. So this photo shows us the univariate distribution of potato lengths from our 24 potato sample. Later on, we'll examine the relationship between length and width, or in statistics terminology, we'll call that bivariate. Bi meaning two, like a bicycle has two wheels. So we're going to look at the length and width together, but right now we're just doing univariate analysis. We're only looking at the length of the potatoes. So we have 24 potatoes in our sample, and the first three things that statistics researchers usually ask is what are the mean, the median, and the mode of this univariate data. So in this case, the length of the potatoes. So the first word, mean, M-E-A-N, is commonly referred to as average. Most people don't call it mean, most people call it average. So average is calculated by adding up all the lengths and then dividing by the number of potatoes. So this is also known as the expected length of the potato. So this can be kind of misleading, because if I were to randomly select one of the potatoes from a bag, I would definitely not expect that it would be exactly as long as the mean or the average length, because they're all different lengths. But nevertheless, it's a very important number, because if I were to stack, let's say, many hundreds of potatoes, one on top of one another, we would expect that the total length would be that mean multiplied by how many potatoes we stacked up. So the word expected, when we're talking about results in statistics, is what we expect when we examine many, many items. So let's talk about the second word, the median. So the median is the number that would split the number of samples in half. So notice that we have an even number of potatoes, 24 potatoes. Notice that there is no potato whose length is 3.898 inches. But we can use that number to say that half of the potatoes are shorter than 3.898 inches, and half of them are longer. So that's what median means. It's the number that if I were to go ahead and compare the potatoes in my sample to that number, half of them would be smaller than that number, and half of them would be bigger than that number. So now we're back to the mean, or the average length of the potatoes. In this case, the mean is 4.008 inches. So here too, even though this is the expected value of potato length, there is not a single potato in the bag that has exactly 4.008 inches as its length. So notice also that it's not the same number as the median. So we notice that as statisticians. We say, hey, wait a second, the mean is a little bit bigger than the median. So we start to think to ourselves, you know what, maybe there's a few potatoes that are very long. Maybe those few potatoes all the way on the right are much, much longer than the others, and they kind of pull the average to get it to be a bigger number. So we'll talk about that skewing, or pulling the average in one way or the other. We'll talk about skewing a little bit later, but the point of the story is the mean and the median don't have to be the same number. The median is just the number where half of the samples are less than it and half of the samples are greater than it. And the mean is simply the average length. And in both cases, there doesn't have to be a single potato that has either one of those lengths. They're just numbers that help us describe the measurements that we took. The last one I want to talk to you about, although it's not particularly interesting in this research, and that's the mode. So mode simply means the most popular of the values. So it's not always useful, and here you see it's very limited usefulness for this particular exercise. So coincidentally, there happened to be two potatoes that had exactly the same length, 4.33 inches. So that's really the most popular length of potato in this bag, or we call it the mode. Mode makes more sense if instead of potato lengths that can take on all sorts of different values, instead we were looking at other numbers like days of the week, or some other measurement that had a very limited number of possible values. So it might make sense to say that, oh, such and such an event most commonly happens on a Thursday. So that Thursday is the mode, or the most common value here. But it's not so important for potato lengths, but I just wanted to tell you what the word mode means. It's usually reserved for when there's a very limited number of values that things can take on. So sometimes we can use a fancy diagram, and that's called a box and whisker plot. And that tells us the stuff I showed you on the previous page, the mean and the median, but it's all in one diagram. So let's take a look at this whisker plot, box and whisker plot. So as you can see, the box and whisker plot gets its name from the fact that there's a box in the middle of the chart, and it has two cat whisker looking lines that come out on the top and bottom. If I drew it sideways, it would come out on the left and right. But here I've got the number of inches all the way in the left-hand column, and then the box and whisker goes up and down. But I could have drawn it where I showed the inches going left to right like the potatoes are organized, in which case the box would be in the middle and the cat's whiskers would be on the left and right. So this is a typical box and whisker plot. So the center line of the box, or a line that kind of crosses somewhere in the box, that is the median. So that is the number, as I told you earlier, that would split our sample set in half. So half of the samples, or 12 of them, are greater than that number, and half of the samples, or the other 12, are less than that. If we had an odd number of samples, then that median would be the number of inches in length of the middle potato. But we've got an even number, so it's half and half. So notice that I only needed the box and whisker plot, and it already showed me what the median was. The second thing is you'll notice there's an X inside the box somewhere. And that X shows you the mean. And here too, just like I showed you on the previous page, I notice, oh look, the mean is a little bit bigger than the median. Maybe there's like a few potatoes that are larger than the others that's kind of pulling or skewing that mean away from the median. So it's interesting to look at. And in one picture, I get kind of all that information that I saw on the previous slide, but now I've got it in one picture. So that's how you read a box and whisker plot. It shows a box and there's a stripe in it, that's the median, and there's an X in it, and that's the mean. So there's a couple of other pieces of information that a box and whisker plot tells us that wasn't available on the previous slide. So let's go ahead and take a look at those. So the very ends of those cat's whiskers represent the range of values that the potato lengths have. So that bottom one is the shortest of the potatoes, and the top one is the longest of the potatoes. So you can see the range of possible values that all of our sample set has. So that's interesting because I can see where the median and the mean fall within that range. So they don't fall smack in the middle of that range. So maybe they're putting a bunch of extra small potatoes in that bag. Maybe if I were looking for large potatoes, that might not be the brand of potato bag that I would want to buy. So you're looking at these numbers and you're seeing, by visually seeing the box and whisker plot, you can get kind of a good idea of where the median and the mean fall within that large range of values you have for your sample set. There's one more thing, last thing I wanted to tell you about box and whisker plots, and that is the quartiles. So quartiles is a fancy name for chopping up the samples into 4 equal number of samples. So we had 24 potatoes, so half of them would be 12 potatoes, so a quarter of them would be 6 potatoes, right? So 6 of the potatoes, or a fourth of them, have lengths that lie between the bottom whisker, that's one all the way at the bottom of the range, all the way to the bottom of the box. So a fourth of the potatoes have that range. And then another fourth of the potatoes have the range from the bottom of the box to the stripe in the box. And then another fourth have the range from the stripe in the box to the top of the box. And then the fourth that are the longest of all the potatoes have a range that is from the top of the box all the way to that top whisker. So basically the top and bottom of the box represent these quartiles, which along with the median and the range show you how the data is chopped up in our sample set. So it gives us a better picture of how the lengths are distributed. So notice those 6 smallest potatoes, the ones at the bottom quartile, between the bottom whisker and then the bottom of the box, all the way at the bottom. That range is a narrower range than the range of the 6 biggest potatoes that are spread out over a bigger range of lengths. So we can learn a couple of extra things about our data and help us understand if it's a good representation just by looking at these median and the mean and maybe a fancier diagram, the box and whisker plot that has that information plus a couple of other pieces of information. Lets us see the whole data without having to necessarily line up all the potatoes on a table. So coming up next, we'll be talking about a histogram. Histogram doesn't chop up the potatoes into 4 equal number of potatoes. Instead, it chops them up into length ranges. And then we'll see how many potatoes fall into each range of length. So that also gives us a feeling about the data. I'll show you that later on. And then understanding multiple values. Right now, we're only looking at the length of the potato. But to verify our hypothesis that potatoes get wider as they get longer, I'm going to need 2 sets of data. I'm going to need the length of the potatoes, and then I'm going to need the width of those potatoes. So we're going to use a scatter plot diagram to show both of those things at once. And then we're also going to use that scatter plot diagram to understand correlation, or how connected those 2 values are. Is it really true that as the potatoes get longer, they also get wider? We'll be able to understand that numerically with the correlation. So none of these are like crazy complicated concepts. You all understand how to measure the length of a potato and how to line them up in length order. And hopefully now you have a more comfortable understanding of some of these vocabulary words and statistics that can kind of be sort of scary sounding because they have different words than you're used to using every day, but they don't really mean anything crazy or wild. They just mean the same sorts of things that you and I understand. Mean means the average length, and median means what length would half the potatoes be shorter than and half would be longer, and a box and whisker plot shows that. Plus also, instead of half, it chops up the data into fourths. So you get even more sharp understanding of the data. So these are very common statistical analysis, and I hope this made it a little bit easier for you to understand. Listen, thank you so much for listening, and I look forward to seeing you next time.